Hi, welcome to this technical overview where we'll look at the highlights of what's new in vSphere 8. My name is Phelim O'Leary. I'm a Senior Technical Marketing Architect here at VMware. So let's just dive right into it. Our agenda for the next 45 minutes or so we'll discuss the vSphere Distributed Services Engine, or what you may have known as Project Monterey. We'll look at some of the new enhancements in vSphere 8 in the areas of vSphere with Tanzu and Lifecycle Management. We'll look at how vSphere 8 can help better prepare you for using artificial intelligence and machine learning workloads. And we'll look at some enhancements in the areas of guest OS, resource management, and security. So first up, let's talk about the vSphere Distributed Services Engine. So you may have heard about this a couple of years ago when we introduced Project Monterey. And this has evolved and will GA with vSphere 8 as the vSphere Distributed Services Engine. And this unlocks the power of the data processing units, or DPUs, for hardware accelerated data processing to boost infrastructure performance. And vSphere 8 makes using these DPUs very easy for you to use these DPUs in your workloads. So what is a DPU? A data processing unit exists today and it lives in the hardware layer, and similar to any PCIe device like a NIC or a GPU. And a DPU contains some compute, some storage, some memory, and some network interfaces, and they can also be referred to as smart NICs. And today our networking, storage, and host management services run in an instance of ESXi, virtualizing the x86 compute layer. So if you had a DPU in your server today, this is what the picture would look like. But we're changing things up a little in vSphere 8. And essentially, in vSphere 8, we're putting an additional instance of ESXi directly on the DPU itself. And this allows us to offload ESXi services, starting with some network and security services from NSX, directly onto the DPU for increased performance. And it also frees up some of the x86 compute power and allows us to give that back to your workloads and applications. At vSphere 8 GA, we'll support greenfield installations with support for network offloading with NSX. Now you might be thinking, does this mean I've got double the instances of ESXi to lifecycle manage? And the answer really is no, because using Distributed Services Engine, it's all lifecycle managed automatically with vSphere Lifecycle Manager. The ESXi installation on the DPU is managed easily through VLCM, and when you're remediating a host, there's just still one remediation event that needs to take place, but both instances of ESXi will get remediated along with the parent host and be kept in version lockstep. Now, to use vSphere Distributed Services Engine, you also need to leverage a vSphere Distributed Switch version 8 and NSX, and with that you can choose the network offload compatibility and select the appropriate DPU in your environment. Network services are then offloaded to the DPU, allowing for increased performance with no CPU overhead. There's also the enhanced visibility of network traffic, security, isolation, and protection you would expect from NSX. So that's a quick overview of the vSphere Distributed Services Engine. Next, let's take a look at some of the new enhancements in the area of vSphere with Tanzu. So vSphere with Tanzu was introduced in vSphere 7, and with that, it brought Tanzu Kubernetes Grid, or TKG. And we ended up with a couple of different versions or iterations, TKG-S, TKG-M, and so on. In vSphere 8, we're consolidating those different Tanzu Kubernetes Grid runtimes into a single unified Kubernetes runtime. So it'll be the same runtime used for deploying Kubernetes on vSphere clusters, public clouds, private clouds, wherever it may be. There's also a new vSphere 8 feature called vSphere Zones, and this is used to isolate workloads across vSphere clusters and also allow you to stretch or span multiple vSphere clusters for maximum availability and resource consumption. Cluster class is a declarative way to specify your cluster's configuration through the open source Cluster API project. Photon OS and Ubuntu images can now be customized and then saved back into the content library for use in Tanzu Kubernetes clusters. And we're bringing Pinniped integration to both the supervisor cluster and TKG clusters as well for federated identity management. So I mentioned vSphere Zones. This is an illustration of what vSphere Zones might look like in an environment. It allows our supervisor clusters and our Tanzu Kubernetes clusters to span multiple vSphere clusters for increased availability. The vSphere namespace will also span the vSphere zones to support Tanzu Kubernetes clusters being deployed again for increased availability and maximum compute consumption. 3 vSphere zones is required for availability. So during workload management activation, you'll have the choice to deploy across vSphere zones or deploy to the single cluster option that we have today. At vSphere 8 GA, a vSphere zone has a one-to-one relationship with a vSphere cluster. The cluster class is an open source specification that is part of the Cluster API project. And Cluster API defines a declarative way to lifecycle manage Kubernetes clusters through an existing management cluster. And in our instance, vSphere Tanzu, the management cluster is our supervisor cluster. So cluster class provides a declarative way to define the Kubernetes cluster configuration, but now it also includes the default installed packages. So the platform team can decide the infrastructure packages that need to be installed at cluster creation. This could include anything from network and storage packages, cloud provider packages, as well as authentication mechanisms or metrics collections. But in addition to defining the default installed packages, after cluster deployment, DevOps users can optionally add additional packages from the Tanzu standard package repository. So they might want to include different packages for ingress to the cluster, different observability packages, and so on. And these are all managed as add-ons through the Tanzu CLI interface. So you have the full flexibility of default installed packages and then customized installed packages after cluster deployment. We're also bringing Pinniped integration to the supervisor cluster and the Tanzu Kubernetes clusters. So in vSphere 7, all authentication was performed through integration with vCenter SSO. And you can still continue to do that in vSphere 8 if you choose, but now you also have an alternative. So with Pinniped integration, the supervisor cluster and the Tanzu Kubernetes clusters can have direct access to an OIDC identity provider without relying on vCenter single sign-on. So single sign-on is not used as a proxy, or it's not involved in any way, shape or form when using Pinniped authentication. Pinniped pods are automatically deployed in the supervisor and Tanzu Kubernetes clusters to support this. So the diagram on screen just illustrates a sample workflow of how the authentication workflow would occur. So number one, a DevOps user would use the Tanzu CLI login to authenticate to either the supervisor cluster or their TKG cluster. Number two, Pinniped integration will federate out to a supported identity provider. The identity provider will then return a login link or login window, and the DevOps user will provide their identity provider credentials. On successful authentication to the identity provider, that's returned to Pinniped, and the Tanzu CLI builds the kubeconfig file needed to access the supervisor or TKG cluster. That's just a sample workflow, and it may be slightly different depending on the identity provider in use. The key takeaway here is that Pinniped federated authentication does not use vCenter single sign-on. So that's an overview of some of the new features and capabilities in vSphere with Tanzu. Next, let's take a look at the area of lifecycle management. So just a quick rundown of some of the highlights, and we'll go into some of these in a little bit more detail. We mentioned DPU support earlier when talking about the vSphere Distributed Services engine. And just to remind you that when you're remediating an ESXi host that contains a DPU, which also has an instance of ESXi running on it, there's still just one remediation event, and both instances of ESXi will be remediated at the same time. Staging support and parallel remediation is coming back to vSphere Lifecycle Manager, and this will allow us to reduce and improve the overall remediation time when you're performing lifecycle operations of your clusters. We have a new technical preview of vSphere configuration profiles, which will be our next generation of cluster configuration management and a future replacement to host profiles. vSphere Lifecycle Manager can now manage the image on a standalone host, so a host that's not a member of a cluster, through the vSphere APIs. And the VMware Compatibility Guide will also list Hardware Support Manager features that are compatible with VLCM features such as staging or parallel remediation. So before we dive into some of the new features, I just want to bring some deprecation awareness to your attention. So baseline lifecycle management, or what you may colloquially call update manager, is deprecated in vSphere 8. And this means that the baseline lifecycle management is still supported in vSphere 8 and will be supported for the lifecycle of vSphere 8, but that vSphere 8 will be the last release that supports baseline lifecycle management. So you still have plenty of time to start transitioning your clusters over to using the declarative image way of doing things, and the update manager method of doing things will no longer be available in the next major release of vSphere. I mentioned staging is coming back to vSphere Lifecycle Manager. So we had this in the past with some of the baseline way of doing things. We now have it again with the image way of doing things. And this allows vSphere Lifecycle Manager to pre-stage the update payloads down to the ESXi host in a cluster in advance of the remediation event. And this is good because it reduces the overall time needed for the host to spend in maintenance mode. So previously, without staging the payloads, the actual update binaries themselves would only get sent down to the host after the host was placed into maintenance mode. So now you can do this without the host being in maintenance mode and while it's still running your applications and your virtual machines. Firmware staging can also be performed with a supported hardware support manager. This can be dependent on the hardware support manager itself, which may require future updates to their own environments. And it may also depend on the hardware component that's involved as well. Not all hardware components will support firmware payload staging. Staging your payloads is also useful in instances where you may have edge clusters or robo clusters where the link between vCenter and ESXi may not be the most stable or high bandwidth. So you can ensure that the updates are staged locally to the ESXi hosts in advance and have more confidence that the remediation event will succeed. Parallel remediation has also come back to vSphere Lifecycle Manager, and as the name suggests, allows us to remediate multiple hosts in parallel. This will significantly reduce the overall lifecycle operation time of a cluster because we will be able to do clusters or hosts in batches. At vSphere 8GA, the vSphere administrator needs to place the desired number of hosts into maintenance mode that they wish to remediate in parallel. And the vSphere administrator can choose to either remediate all those hosts in maintenance mode or define a set number. So, for example, remediate 2 hosts at a time, remediate 3 hosts at a time, or remediate all hosts at a time. Now, the reason that the vSphere administrator needs to decide how many hosts go into maintenance mode is we have to do some work under the hood to make DRS a little bit more intelligent, to identify what is the optimal number of hosts we can place into maintenance mode at any given one time. So right now we're leaving it up to the vSphere administrators, who know their clusters, know their workloads best, to observe and decide the number of hosts that can go into maintenance mode at any given time. Now, also in the area of lifecycle management, or backup and restore, we're introducing what we call a distributed key value store onto the ESXi hosts themselves. And this is going to be involved in keeping the cluster state and reconciling that information with vCenter. So up until now, we've always assumed that vCenter is the source of truth when it comes to pretty much everything when it comes to configuration and state in a vSphere environment. But sometimes that's not always the best approach to do things from. For example, if a vCenter is restored from backup, that backup may be a couple of days old, it may be a couple of weeks old, and there's going to be a lot of information that may have happened between the time the backup was taken and when the restore event happened. And more often than not, the ESXi hosts have that information. So the idea behind the distributed key value store is that when vCenter is restored from backup, it will communicate with the clusters, and the clusters will reconcile the missing data to vCenter. So vCenter can absorb that missing information between the time the backup was taken and a restore event occurred. In vSphere HEA, the first piece of information that we're going to be working with is host cluster membership. So what hosts are members of what clusters and so on will be reconciled with additional configuration and state planned for support in a future release. So I think the best way to help understand that is to illustrate it in an example. So if we take this following example where we have a vCenter and he's currently managing 2 ESXi hosts, okay, the 2 green ESXi hosts in the diagram. So let's say the vCenter backup was taken on a Monday, and then we added more hosts to the cluster. We added a 3rd host to the cluster on Tuesday. And then on Wednesday, we had a catastrophic issue. The vCenter was completely unrecoverable and we had to restore from backup. So vCenter gets restored from backup that was taken on Monday. So it's essentially gone back in time, and it's going to come online and it's going to kind of question to the cluster, you know, I've been restored, what's new? Because at this point in time, it has no awareness of that 3rd ESXi host. So the distributed key value store will reconcile that missing information with vCenter and allow vCenter to update its own records with the most up-to-date and correct cluster state information. So that's an example of how the distributed key value store will work in operation. And as I said, we're looking to build upon this to add more and different types of state and different types of configuration in the future to make vCenter more resilient in the event of being restored from backup. Now, it's important to note that this is not a replacement for good frequent vCenter backups. This is just an additional recovery enhancement for that delta information between when a backup was taken and when a vCenter was restored. So now let's talk about vSphere configuration profiles. So in vSphere HEA, we introduce a technical preview of what we're calling vSphere configuration profiles. And as I said earlier, this is going to be our next generation of cluster configuration management and will be an eventual replacement for host profiles, but host profiles continue to still be supported in vSphere 8. You can still use them in vSphere 8 to their full potential. And the end goal of vSphere configuration profiles is pretty much the same as host profiles, right? It's to apply a cluster-wide configuration, a consistent configuration across all hosts in your cluster. So the end result is the same, it's just how we're getting there is a little bit different. Rather than define separate entities in the form of host profiles and have them attached to clusters or hosts, the cluster configuration is defined and contained within the cluster object itself. So you don't have to worry about attaching anything to anything else. Everything is contained within the cluster object itself. And you can export that configuration. You can export it as a JSON document and import that configuration into other clusters or even other vCenters if you wish. And the same principles apply in that all hosts in the cluster will have a consistent configuration. If there's configuration drift, that's monitored for and will raise alarms and notifications, and a vSphere administrator can remediate the configuration drift. Now, vSphere configuration profiles is still under active development, and future releases of vSphere 8 will expand and enhance its support. But I do urge you to take it for a test drive, take it for a spin, and give us your feedback. That's why it's released as a technical preview, to get it into the hands of as many customers as possible, so that we can get real world feedback and make it the best that it can be. Next, let's talk about some of the areas that we're helping in consuming hardware for use in artificial intelligence and machine learning workloads. So AI/ML is a really fast growing area, and it's getting into all sorts of industries and all sorts of workloads. And those workloads are getting larger. They're working with larger models for computation and for AI/ML spaces. And one thing that these workloads need is hardware accelerators. And that can typically be in the form of GPUs or a combination of GPU and a dedicated NIC, for example. And with device groups, what we're doing is we're working with vendors, and they are able to define common PCI devices, either NICs and GPUs together or GPUs and GPUs together. And these may share a common PCI switch or a direct interconnect. Direct interconnects could be something like NVIDIA's NVLink, where you have a direct bridge between two GPUs, and you're not necessarily needing to go up to the PCI switch. And these are going to be defined at the hardware layer by the hardware vendors themselves and presented to vSphere. And vSphere will discover these groups and easily be able to attach them to virtual machines as a single unit. And this is important because for certain workloads that need complementary hardware devices, this takes the guesswork or the manual work out of it from the vSphere administrator side. The devices are already grouped at the hardware layer and can be presented as a single unit to the virtual machine. Now, one of our first partners that will be supporting device groups is NVIDIA, and they will release an upcoming compatible driver to support device groups. And as I said, to add these to a virtual machine, there's no difference or there's no change to the existing workflows if you're adding hardware to a virtual machine. You'll go into your virtual machine settings, select Add New Hardware and PCI Device. And if there's device groups present, they'll simply be discovered and show in the list. So in this example, there's two device groups showing. One is for a 2 GPU pairing, and you can see NVLink is in the name, indicating that they're using a direct interconnect. And the second one is a combination of GPU and dedicated NIC. So depending on the workload in question, you can choose the appropriate device group that meets that workload's needs. Now, vSphere DRS and vSphere HA are aware of device groups, and they'll work with the device groups in terms of VM placement. So initial VM placement, DRS will make sure that the VM powers on or gets placed on a host that can satisfy the device group, And vSphere HA will always fail over the virtual machine to a host that again can satisfy the device group if available. Now, another area in the AIML space is what we're calling device virtualization extensions. And this may not necessarily be limited to AIML workloads, but it involves virtual machines that are consuming physical hardware devices. So it doesn't necessarily have to be limited to AIML workloads. It can be any workload that is consuming a physical hardware device. And in previous releases, VMs consuming physical hardware devices using direct path I/O or dynamic direct path I/O were limited in their mobility. So you couldn't do a live vMotion, you couldn't suspend and resume the VM, you couldn't do snapshots. So you lost some of the virtualization benefits when you were consuming physical hardware using direct path I/O. Now, dynamic or device virtualization extensions builds on dynamic direct path I/O and introduces a new framework and API so that vendors can create new hardware-backed virtual devices that does allow for those virtualization features, such as live migration, suspend, resume, and snapshots. So what this means is a new device driver will need to be developed for the ESXi host and also for the guest operating system or the virtual machine. And with those new device virtualization extension drivers and compatible hardware, virtual machines that are consuming these hardware-backed virtual devices can now be live migrated using vMotion, for example, to another compatible ESXi host. So it opens up the benefits of the virtualization that we have with other virtual machines to these VMs and workloads that are leveraging hardware-backed devices. Now let's take a look at some of the enhancements in the area of guest OS and workload. So just a quick rundown on some of the things that we'll talk about in this section, and we'll go into detail on some of these. Like with all versions of vSphere, new versions of vSphere, we bring a new virtual hardware version. And in this version, we're up to hardware version 20. This allows for some compute maximum increases, and it also unlocks a lot of the other features that we'll talk about in this section. We introduce a virtual TPM provisioning policy, which is primarily geared towards helping deploy Windows 11 workloads at scale, but it could be applied to any workloads or any operating system that is leveraging a virtual TPM device. We're making applications or supporting applications to make them migration aware through vMotion notifications. Enhancing the work we did with high latency sensitivity in vSphere 7 by adding high latency sensitivity with hyperthreading. We're simplifying the configuration of vNUMA, and we're increasing some compute maximums, as you might expect. So taking a little bit of a deeper look at virtual hardware version 20, this is just an overview of the top things that hardware version 20 brings. And we've broken these down into kind of 3 pillars. So the first being virtualized hardware innovations. And with that, we're bringing the latest Intel and AMD CPU support. We're also bringing device virtualization extensions, which we just talked about a moment ago. And we're increasing the number of direct path I/O devices that a virtual machine can support. In this release, it's going up to 32. In the area of guest services for application, we're introducing something new called vSphere datasets, which we'll speak about in a moment. We are allowing applications to become migration aware with vMotion notifications. And we're introducing support for the latest guest operating systems, as we do with each hardware version release. In the areas of performance and scale, we're allowing up to 8 vGPU devices per virtual machine. We're introducing device groups, as we said, to make it very easy for AIML workloads to consume the right hardware. And we're introducing high latency sensitivity with hyperthreading. So we'll take a look at some of these in a little bit more detail in the next coming slides. So the first thing we'll talk about is our virtual TPM provisioning policy. And the reason why we're kind of targeting this towards Windows 11 is that Windows 11 requires vTPM to be present in all virtual machines or physical machines. But these principles could be applied to any workload that is leveraging a virtual TPM device. And when you're cloning a VM with a vTPM device, that can introduce some security risks, because the TPM secrets are also cloned, and so it opens up some potential cross-contamination there of secrets. In vSphere 8, vTPM devices can be automatically replaced during the clone or template deployment operations. So this allows best practices that each VM contain a unique TPM be followed, and therefore improves vSphere's support for Windows 11 deployments at scale. So it'll allow you to deploy Windows 11 from template, deploy large amounts of Windows 11 desktops, but ensure that each instance has a unique TPM device. Now the default behavior is still copy, because we didn't want to change what the default behavior is in vSphere when it comes to doing a clone. But when it comes to the TPM provision policy, you do have the option through a vCenter advanced setting to make the default operation be replaced when it comes down to vTPMs. So best practice would be to replace the TPM device on all VMs during deploy from template or even during clone. Just need to be aware that if you're doing a direct one-to-one clone, and the virtual machine is using features like Windows BitLocker or Windows Hello, these features use TPM-backed secrets, and if you do replace the TPM device in those instances, those Windows features may cease to function. So you need to be careful that you're doing the right operation for your respective use case. And we're also introducing something called vSphere vMotion notifications in vSphere 8. So we've often take vMotion for granted. It very seamlessly can migrate a running virtual machine from one ESXi host to another, or even from one vCenter to another. And for the most part, virtual machines and applications running within them are completely transparent. They have no awareness that the migration has occurred, and they'll happily continue working and running without any bump whatsoever. But there are certain applications that cannot tolerate the stun times associated with vSphere vMotion, and these stuns are in the milliseconds. But there are some applications that are extremely sensitive to that, like voice over IP applications could result in calls getting dropped. Clustered applications, it may interfere with the heartbeating between clustered applications and cause an unintended failover, for example. So with vSphere vMotion notifications, what we're allowing to happen is that ESXi will send a notification to a virtual machine when a vMotion event has been triggered. And using VMware tools within the guest operating system, an application can intercept the notification and be told a vMotion event has been triggered, and the application can perform some work. And this could be anything from stopping services to quiescing the application to gracefully failing over, whatever it may be. And there's a configurable timeout as well, by where the application can decide a certain amount of time in seconds or minutes to perform this work, after which the vMotion will simply occur. Now it's important to know that the application can't decline or prevent the migration from occurring. It can just delay it up until the defined timeout value. Now applications need to be rewritten to support vMotion notifications natively, so it's not something that applications are compatible with out of the box. Or, a partner application could be written like a small little Python application, could be written as an intermediary that intercepts the vMotion notifications and can interface with the main application to perform any work needed. Once the application has performed what it needs to do, it can acknowledge the notification and allow the vMotion to complete. But as I said, if the application does not respond within a defined timeout, which is user configurable, the vMotion is just going to happen regardless. Another important aspect to be aware of when you're using vMotion notifications and it's turned on for a particular virtual machine, these virtual machines are automatically excluded from automatic DRS load balancing migrations. So you still will be able to manually migrate a virtual machine. You'll still be able to put a host in maintenance mode and it will be automatically migrated. But for runtime DRS automatic load balancing, these VMs will be excluded from that equation. Another feature to help support these very sensitive applications, primarily, for example, in the telco space, they often require increased support for latency sensitive applications. We introduced high latency sensitivity in previous releases, and in vSphere 8 we're introducing high latency sensitivity with support for hyperthreading. And this is designed to support those hyperthreaded workloads and deliver improved performance for those workloads. And this means, when enabled, that the virtual machines vCPUs are scheduled on the same hyper-threaded physical core rather than being potentially spread across multiple cores. And this is a feature that requires virtual machine hardware version 20 and is easily configurable in the virtual machine's settings under the latency sensitivity section. Another area for those kind of niche workloads or very sensitive workloads that you want to squeeze a lot of performance out of, we also have a new simplified vNUMA configuration. So vNUMA has existed since, I think, vSphere 5, and up until now required you using advanced parameters or CLI-based options. But now with vSphere 8 and hardware version 20, the vNUMA topology is exposed to the vSphere client. So it's very easily configurable right there in the UI. And you can also manually assign devices to NUMA nodes as well right in the UI. There's also a handy tile right there on the VM summary page to illustrate the current CPU topology. Now, vSphere datasets is the last feature we'll speak about in this topic, and this is a new way for small, infrequently changing data to be shared between the vSphere management layer and the guest operating system. Some use cases for this might include things like a guest deployment status, where an application may be writing its current status to a vSphere dataset, and that can be read from the vSphere side using vSphere APIs. Or a vSphere administrator could push some configuration parameters to a dataset that could be consumed then by the virtual machine, for example. So it's bidirectional, but you can be also controlled with proper permissions. So you can define who has read-write access. Or no access at all. It could be something that just the vSphere administrator can see and the guest operating system cannot. vSphere datasets are stored with the virtual machine files. So there's a new file called .dsd, and that's stored with the virtual machine files, and it'll travel with the virtual machine. So if you do a migration between clusters, between hosts, between vCenters, the vSphere dataset will travel with the virtual machine. vSphere datasets can actually be even defined and created by the vSphere administrator even when the virtual machine is powered off. But obviously for the guest operating system to interface with the dataset, it needs to be powered on and it needs to have VMware tools installed and running. And this requires hardware version 20 also to take advantage. Now, just a quick note on vSphere scalability. So as with each release, we try and push the boundaries of scalability. And in vSphere 8, vSphere Lifecycle Manager can now manage the image for the full cluster size of 96 hosts per cluster. Keep in mind that the vSAN cluster size limit of 64 hosts still remains true. We can now have up to 10,000 VMs per cluster, and we saw that we're increasing some vGPU resources also. Now, for all the configuration maximums that vSphere 8 brings, check out configmax.vmware.com. Didn't want to put a table up on the screen because we're constantly doing additional scalability tests, and the maximums are change at GA, they'll change it in various update releases. So for the latest and greatest information, always check out the configmax.vmware.com for all the vSphere scalability numbers. Now, just a couple of brief notes in the area of resource management. And the first one being some enhanced DRS performance with vSphere memory monitoring and remediation version 2. So we introduced vMMR in vSphere 7 update 3. And in vSphere 8, the DRS performance is significantly improved by better leveraging these memory statistics. And this results in more optimal placement decisions by DRS for VMs without affecting their performance and/or resource consumption. We're also introducing vSphere Green metrics. These are 3 new metrics that will monitor the energy and carbon equivalent emissions of the vSphere infrastructure and workloads. And you'll be able to take these metrics, combine them with your own data on your energy consumption from your energy provider, and be able to illustrate the carbon emission equivalent of the infrastructure at both the host level and the virtual machine level. So there's 3 new metrics: one to calculate the power capacity and usage of the virtual machines, or how much power the workloads are using. The power capacity of usage system, so how much power is just being used by the ESXi host system activity, so everything the host is using that is not attributed to VMs. And also the power capacity usage idle, so how much power is consuming just by the host being on and being idle. And VMware Area Operations will be able to ingest these metrics and illustrate the carbon intensity, carbon emission rates, and even do some predictive models of where things, based on trend, where spikes may happen at certain times or certain days. And lastly, we'll touch on some of the areas that we're making improvements in the area of security and compliance. And we're always making vSphere more secure by default. So as the releases go on, these kind of topics become, I suppose, less and less verbose because we're more secure out of the box. And along with some of the things like VTPM provisioning policy, vSphere 8 also builds on our virtual SGX support by taking advantage of the latest updates from Intel. We're only going to speak in TLS 1.2 in vSphere 8. Now, this is how vSphere 7 operates today, but you still have the option to fall back to TLS 1.0 or 1.1. In vSphere 8, it's TLS 1.2 or nothing. There's no option to fall back. One of the biggest things we've done is to prevent untrusted binaries from running. So this means that no executables can run on ESXi unless they've been installed from a signed package or a signed VIB. So this makes it so that some custom built VIBs may need to get updated, may need to get signed, but it also means that no rogue VIBs can be installed. You can back out of this setting, and if you do, for whatever reason, there is an undismissible alarm So that's a big clue that someone has turned this off. And we don't recommend doing so unless under the guidance from VMware support. We always recommend that you leave SSH disabled. You know, it's a pretty big attack vector if it's left enabled, unless you're doing some troubleshooting or you're, again, working with VMware support. So to help encourage that, we're introducing an automatic timeout for SSH, where it will disable itself again. Now, this timeout is configurable so that you can work with it so that it won't interfere with what you're doing when you do need to have SSH enabled. And along with that, just in general, we're making vSphere more secure out of the box. For everything in terms of security, you can check out the vSphere 8 security configuration guide. Now, it's now part of the vSphere documentation, and you can find it there also. You'll also be able to find it on core.vmware.com. And it's synced with some of our other compliance guidance too, like the DISA STIG, and has brand new and modernized Power CLI examples to make your life a little easier. So that wraps it up for a technical overview of what's new in vSphere 8. It's not everything that's what's new in vSphere 8. There's a lot more that is available in the product. So please do check out the vSphere YouTube channel. That's where additional videos and content will get posted. We sometimes do vSphere live streams there as well, where we talk about different topics and have experts answer the right questions. For everything security, you can check out the VMware security advisories. So this is a good mailing list to sign up to get notified when there are new VMware security advisories. And for everything from technical marketing, check out core.vmware.com. We have a dedicated vSphere 8 landing page available there. We will find out all our content about vSphere 8. There's also the existing content on vSphere 7 and new content on things like vSphere Plus. So hope you'll check that out. Leave us some comments. Hope you enjoyed this video on the technical overview of what's new in vSphere 8, and I'll see you again in the next one.